All right, we're taking a look at 4.3. We are going to be solving systems of equations algebraically using elimination. We're going to be doing that so that we can find the solution to a system of equations algebraically. And we'll know that we're able to do it when we can take two equations that are in standard form and find the solution for both x and y. So why elimination? With graphing, it's easiest to graph if, one, we have a provided graph, and two, both equations are in slope-intercept form. Then we can just plot the b and then count using our m and graph our lines and then look for where our lines cross to find our solution. With substitution, if we have one equation in standard form and one equation in slope-intercept form, we can substitute and take that piece and plug it in and solve. Elimination, when both equations are in standard form, so that's like ax plus by equals c, so just like our example up here, when both of them are in standard form, we typically use elimination to solve for then the remaining variable. So there are two types here. The first type is a variable that can be immediately eliminated. So if we're looking and comparing these two problems, so my top problem and my bottom problem, what I'm looking for is two terms, right? So either the x's or the y's, and I'm looking for the same exact number but opposite signs. So right here I have a negative 3x and a positive 3x. Those have the same number, the same value, but different signs. And what that does is they cancel each other out. Remember, this is called elimination. And so we are looking for terms that will eliminate each other. Because if we combine these equations vertically, what will happen is 3x and negative 3x will cancel each other out so that we're only left with a y value to work with, and then we can solve for y. So that's the first type. These are really nice. The second type is that we have to multiply one or both equations by a number in order to make the variables eliminate. So if we're looking here, our variables, we don't have like anything that's going to cancel each other out. They're not going to cancel or eliminate. Our x's or our y's will not eliminate in just leaving these equations how they are. However, mathematically, we are allowed to change an equation by whatever we want, one or both equations by whatever we want, as long as we are applying it to everything. So we can multiply whatever we want to this whole equation. I could multiply 55 to this whole equation if I wanted to. And think about an equation on a scale. Like if we had like a scale here and it was balanced, as long as I multiply everything by the same value, then our scale remains balanced. It's still equal. So the trick with these ones, with type 2s, is figuring out what number should we use to create a situation where the variables will be eliminated like here. And so that's what we're going to be practicing. So here are some steps. We're going to check for elimination potential. So just like I did up here in type 1, I want to make sure is what has the potential to be eliminated. If I'm looking at type 2, the potential, the easiest to eliminate would be our x values. If I multiplied a negative 2x to my top term, that would create a negative 8 that would make it eliminate. So I'm looking for elimination potential. In order to get these two to eliminate, I would have to multiply a 5 to the top and maybe like a negative 2 to the bottom to give me a negative 10 on top and a positive 10 on the bottom. So we could change both equations if we need to, but we're checking for elimination potential first. The next thing we're going to do is we're going to change the equations by multiplying the number that would cause elimination, or to create terms that will cause elimination. So we're gonna create terms that cause elimination. Then we can combine the equations vertically to eliminate the variable, to eliminate either x or y, leaving us with one variable that we can solve for. Once we've solved for it, we will substitute it back in, and then we will write our answer as an ordered pair. Mathematically, this is pretty easy. Mathematically, this is not bad. I would say maybe it's not as many steps you end up doing as you do with substitution. However, as a concept, it is slightly more difficult. So it's a little bit more conceptual. So we're just going to work through each one of these and you'll kind of see how they work. So I'm checking for elimination potential here first. And I see that I have a positive 4x and a negative 4x. I don't have to do anything to change either of these equations to get them to cancel out. They're already set up so that they would cancel out. So here's what I get to do. I'm going to combine these equations. I'm going to take 4x and negative 4x, and when I combine them, they cancel out. That's exactly what I want. I'm going to take negative 4y and positive 1y, and when I combine them, I'm left with a negative 3y. I'm also taking, let me use purple here. I'm also taking what they equal, negative 12 and positive 15. When I combine them, I get a positive 3. So the hardest thing is figuring out what to use to make them eliminate. Once we start combining vertically, now I have a one-step equation. I'm going to divide negative 3 from both sides to get y by itself. Now that I've found what the value of y is, I can plug it into either my top equation or my bottom equation, whichever one I want, to solve for it. So I'm going to plug it in for my top equation just because. It doesn't really matter. You'll get the same value. So 4x minus 4, and now I'm replacing y with negative 1 equals negative 12. I'm going to multiply these up. That's going to make positive 4. Rewrite everything else. Now I'm solving a two-step equation. So I'm subtracting 4 from both sides, and then dividing 4, and x equals negative 3. Oh, sorry, nope. I didn't actually put 12 and negative 4 together. I got way ahead of myself. That's 16, and then negative 16 divided by 4 is negative 4. So those are my two values, and then I'm writing them as an ordered pair. I'll do that in this box right here. Parenthesis, negative 4, comma, negative 1, close parentheses. Okay, let's take another look here. Elimination potential. This one the y's can eliminate. I don't have to change anything to get them to cancel out. So all I'm going to do is combine them vertically. So I'm going to take 2x minus 8x and get negative 6x. 3y and negative 3y cancel out. 16 and 8 is going to give me 24. I can now divide negative 6 to both sides, and x equals negative 4. I'm going to use that, plug it into either equation. I'm going to use my top one. 2 times negative 4. Now remember, last time we had to plug in for y. This time I'm plugging in for x. So make sure that if you're substituting a negative 4 in, make sure you send the negative 4 to the correct class. Make sure it's substituting for the right teacher, okay? Plus 3y equals 16. I'm going to multiply these up to get negative 8 plus 3y equals 16. And then solve my two-step equation. Add 8 to both sides, 3y equals 24. Divide 3 to both sides, and y equals 24 divided by 3, which will be 8. Okay? And then we always write our answers in ordered pairs, so negative 4, comma 8. Okay, let's take a look at number 3. So number 3, for in terms of elimination potential, these x values have the potential to eliminate. However, they're both negative, which means they wouldn't eliminate. If I were to add these up how they are right now, I would get negative 6x, and I want 0x. So what I'm going to do, and this could be applied to either the top or bottom equation, is I am going to multiply in a negative 1 to every term. I can change an equation by whatever I want, multiplying, as long as I do it to every term. So if I do a negative 1, essentially that's just going to give me opposite signs. So negative 1 times negative 3 gives me positive 3x. Negative 1 times y gives me negative 1y now. And negative 1 times 24 gives me negative 24. I'm not going to change my top equation. And now I have the potential to eliminate these, so I'm going to combine them vertically. I'm going to say 3x minus negative 3x plus 3x, negative 7y and negative 1y is negative 8y, and 24 minus 24 is 0. So as I solve this out, y equals 0. And we can get that. We can get a value equaling 0. In this space here, I'm going to now substitute 0 in for y. It doesn't matter which equation you use. Even if you use your new equation, doesn't matter. Just make sure that you copy it down exactly how it is. If you leave out any signs or change signs or values, then it will throw your answer off. So I'm just going to use my bottom equation here. Your choice. Whatever looks easiest to you. You have a little bit of freedom there. So instead of y, I'm going to plug in 0. Well, that really just means I can write negative 3x equals 24. I can divide negative 3 from both sides, and x equals negative 8. So for this one, my ordered pair is negative 8, comma 0. Okay, let's keep cruising. Again, elimination potential. I see that my y's could eliminate, but one of them needs to be negative. This time I'm going to apply it to the top equation. So I'm going to take a negative 1, multiply it into every term. And that's going to give us negative 5x minus 7y equals negative 7. It just changes all of the signs. If it was positive, it becomes negative. If it's negative, it becomes positive. This one, 6x plus 7y equals 14. And again, the whole purpose of this is to create this scenario here. So I'm going to combine these vertically. A negative 5x positive 6x, thinking ahead, is 1x. I could also just write that as x. Negative 7y positive 7y cancels out. And then equals negative 7 and positive 14 makes 7. So x equals 7. There's nothing else to solve for in this one. Nothing to move, nothing to do. I'm going to take that, plug it into my original equation. Anything that I want to plug it into, this one, or this one. Doesn't matter. So I'll just plug it into, I'll plug it into the top one. So I'm going to say 5 times 7, because that's my x value, plus 7y equals 7. So that's 35. I get y equals negative 4. I had x equals 7. So as an ordered pair, I would say this is 7 comma negative 4. If we were to go through all of the work to change this to solve for y and then graph it on a graph, the lines would cross at 7, negative 4. Okay, let's take a look at some problems that require us to do more than just apply a negative. So here I'm looking for elimination potential. And I'm always looking for the easiest way to do this. So I'm looking for least common multiples, like I'm kind of using my factors and my understanding of multiplication to think through these. So if I'm looking here at my x's, I could multiply the bottom 3. I can multiply this bottom row by 3, and that would give me a positive 9x. And that would create a situation where my x's cancel each other out. If I'm looking at my y's, there's less elimination potential there. I would have to multiply both. I would have to multiply my 5 up top here by a 4 and my 4 down here by a 5 to make 20s to cancel out. So I could do that, but I'm seeing here that I could multiply my bottom equation by 3. That's kind of my magic number, because when I do that, if I had negative 9x on top, when I multiply by that 3, I get a positive 9x on the bottom, and those are going to eliminate. That's exactly what I want. Minus 12y equals 36. And if I needed to, I could multiply by a negative 3, but in this case I didn't need to. So 3 times 12, 36. Okay, I already kind of boxed it because I knew that those would cancel out. 5y minus 12y is going to give us a negative 7y. And we have a negative 15 and a positive 36. Signs are different, so we'll subtract and keep the sign of the larger number, 21. I'm now dividing negative 7 to find that y equals negative 3. Now that I have that, I can plug it in to any of the equations. This one, the new one, whatever I want. I'm going to plug it into my bottom equation. So 3x minus 4 times negative 3, I'm replacing y. Those make a positive 12. That means I'm going to subtract 12 from both sides. And 3x equals 0. When I divide 3, x equals 0. So here are my two values as an ordered pair, 0, negative 3. All right. And keep looking at this. Again, we're looking for elimination potential. These don't have great potential to eliminate, but these ones do, because I could just get away with multiplying my top by a positive 2. I don't need to change my signs, so I can just leave it as a positive 2. That's going to give me 8x minus 10y equals negative 44. Don't forget that last one. Everything gets multiplied. And then negative 5x plus 10y equals 20. Now I have elimination. 8x minus 5x, 3x. These cancel out. Equals, that's going to be negative 24. I divide 3 to both sides, and x equals negative 8. I can now take that, plug it into my any of my original equations. I'm going to do it to my second one. And those are my two values, negative 8, negative 2. All right, the last two. These ones, I made sure to have no elimination potential. So I can't get away with just multiplying one number from this set, and I can't get away with multiplying just one number from my second set to get these to cancel out. So with this one, and this is kind of a general rule, you can always, if you can't think of factors like what common number could we make this, or what common number do these have, you can always just multiply. So whatever I have down here can multiply with my top, and whatever I have on my top can multiply with the bottom. We're looking for opposite signs. This is tricky conceptually to pick the number that we need to use, but the math isn't that bad. These are going to be some larger numbers, but it's not that bad. So I'm going to eliminate my x's. And the way that I'm going to do that is they already have opposite signs, so I don't have to mess with positive or negative, or with figuring out if I need to use a negative or not. I can just use positives. And I'm just going to multiply my whole bottom row by 10, my whole top row by 9. I got that 10 from here. I got that 9 from here. So this is going to give me negative 90, 90x minus 72y equals, I'm going to do 16 times 9 to get 144. In the bottom, which I'll do in blue, 10 times 9, positive 90. And when we use our opposites for these, this will happen every time. They're going to create our terms that eliminate. And then I have 10 times negative 7, so that's negative 70. This is kind of easy. And then 10 times 14, which is going to give me 140. So let me just double check my signs and make sure that I didn't skip anything that I needed to not skip. And I think we're looking good. Okay. So I'm going to combine these vertically. Again, if I goof on any of the actual math, the process is the same. So, oh, I forgot to write my y in here. So signs are the same. We're going to add these up, and I'm going to get negative 142y equals, I'm adding these up, and this is going to be 284. And I'm dividing negative 142. You shouldn't have numbers this big on the practice, but if you can see it with something difficult like large numbers, you can do it with smaller numbers. We're saying 284 divided by 142, and that's negative 2, because we had a positive divided by a negative. So all of those big numbers just to get a negative 2. Now I can plug that negative 2 into this equation, this equation, this equation, or this equation. Whichever one looks easiest to you. I'm going to choose the bottom equation. 9x minus 7 times negative 2 equals 14. We're multiplying these up. That's a positive 14. I'm already kind of seeing this is going to zero out because when I subtract it to both sides, those make 0. So I'll just finish it out mathematically, but I saw that it was going to be 0. So we're saying 0 comma negative 2, x comma y. All right, same idea here. I could cancel out my x's. To cancel out my x's, this way. To cancel out my x's this way, if I multiplied a 4 to the top and a 5 to the bottom, that would make negative 20 and 20. Could also cancel out my y's if I multiplied a 4 to the top and a 3 to the bottom. I don't have to worry about signs because I have opposite signs. So I'm going to cancel out my y's in this one just for fun. So if I multiply a 4 here, I'm going to multiply a 3 down here. So up top, I multiply a 4 to everything. That's going to give me negative 20x minus 12y equals negative 44. On the bottom, I'm going to get 12x, positive 12x. I'm going to get positive 12y equals positive 12. If you notice, they all kind of scaled up. So if I had 4, 4, and 4, when I multiply to 3, I'm going to get 12, 12, and 12. Okay, so now I'm ready to combine these because now I have terms that will eliminate. So I'm going to combine these vertically. That's going to give me a negative 8x. Our y's cancel out equals, signs are different, so we'll subtract. And this should give us negative 32. We can divide negative 8 to both sides, and x equals positive 4. Now that we know what x is, we can plug it in here, 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 or here, whatever you want. I'm going to keep with my theme and just keep using the bottom one. 4x, and then instead of x, we're putting a 4. So 4 times 4 plus 4y equals 4. That's 16. We're subtracting 16 from both sides. So 4y equals negative 12. And then we're dividing that. So y equals negative 3. So I find my x, comma, y in parentheses, and that's our solution. So when we are solving using elimination, again, we check for elimination potential. Not all of them are going to take all of this work where we're changing things. We change equations by multiplying a number that would cause them to eliminate. So if they don't have immediate elimination potential, then we're going to want to multiply in, like sometimes it's just a negative. Sometimes if they have the same number but we need different signs, we can just multiply in a negative. Sometimes we have to change and scale up all of our numbers to get them to cancel out. Sometimes we need to change both equations and scale both of them up to give them numbers that will cancel out. Okay. One of the examples that you didn't see here was in needing to change a sign. So I'm just going to quickly kind of come up with an example. I don't know how well this is going to work on the fly, but let's say I have a negative 2x plus 5y equals, gosh, I don't know. I'm making things up. So 12. That might be horrendous. I have no idea. And then, in fact, it is horrendous. I'm going to say 15. Okay. And then let's do another one where I have 3x, negative 3x, plus 6y equals 18. No idea. Okay, just an example. And if I wanted to get rid of my x's for my top equation, I can multiply like a 3. And my bottom equation, I can multiply a 2, right? And that's going to give me, that'll turn that into a 6 and that into a 6, so they'll like have the potential to cancel out. The problem is that one of my signs needs to change as well. So I could either multiply a negative 2 to the bottom, so that I get a positive 6, negative 6. I could also multiply, or instead of, I could multiply a negative 3 to the top to give me a positive 6 here and a negative 6 here, so they cancel out. So sometimes you do have to be aware of, do you need to include a sign, like a negative, to get your signs to be opposites as well. Okay?